From this mountaintop more than a half-century ago, the Palomar Observatory peered more deeply into the universe than ever before. One of the top astronomers of the day was a man named Edwin Hubble, who you may have heard of. Now NASA's Hubble Space Telescope is celebrating a birthday, the Big 2-0, and what a life it's had.
Next couple of hours, there will be numerous commands sent to begin deploying the arrays.
At the beginning, there was actual resistance by many astronomers who used the argument that it would be better to build 20 more 200-inch telescopes than to build one Hubble.
Ground-based telescopes, even though they're bigger, are covered over by an ocean of atmosphere. So instead of making a small, tight dot, a star is a blob. And this erases all the details that you might want to see in astronomical objects.
Finally, we started to get major figures in American astronomy to speak up and advocate. And then it became feasible to build a telescope that would have the scientific impact of Galileo's first telescope.
No one ever anticipated Hubble would have a lifetime quite this long, so it's allowed you to do a whole set of things that never were feasible before.
You point your camera at a blank spot of the sky, you open the shutter, you walk away for a month, you come back and you close it. It's a 1 million second exposure of the sky. The deepest optical image ever taken of the universe.
What are we looking at here? Why is this so revolutionary?
So this is a very ordinary spiral galaxy. It looks very much like the Milky Way. As you go a little further back, you can see some of these galaxies or the stuff up here. So you're looking back at a time when the universe had many more of these things than these. And then if you go all the way back, and this little red thing is an example of that, that is actually a galaxy. That is a galaxy whose light was emitted when the universe was approximately 1 billion years old. Kind of blew us all away. I mean, we all thought this was unbelievable. I mean, it's wonderful. That's why we do science.
You would see something like this.
The reason we call it dark matter is, first of all, very literally, it doesn't radiate, it doesn't produce any light, but maybe also because it's sort of mysterious and we don't quite know what it is.
If we can't see dark matter, how do we know it's there?
Well, we've known about the presence of dark matter around galaxies and around galaxy clusters for a number of years from the motions of galaxies. Hubble has actually given us a new way to probe dark matter, and that's through something called gravitational lensing. Here we have a Hubble image of some galaxy clusters. The streaks are just normal galaxies, and as the light from those galaxies has traveled to us, it has passed through a big lump of mostly dark matter, and matter can bend that light like a lens and cause the galaxy to look distorted as though we were looking at it in something like a funhouse mirror. So there's another interesting image of two galaxy clusters that are colliding with one another. The blue here is representing the dark matter, and the pink is representing hot gas. We have another picture. This is a three-dimensional map of dark matter that was constructed from measuring those distortions of galaxies by gravitational lensing. What I want to point out here is that the scale of this map is absolutely huge. So an individual galaxy would be a little tiny point.
It sounds like dark matter is kind of a scaffolding of the universe.
That's exactly right. So we actually believe that if there were no dark matter, if there were just the normal matter connected to galaxies that we see, galaxies themselves would not have been able to form. So dark matter is really what allowed, in some ways, us to be here now.
Black holes are places where gravity has pulled matter together so tightly that even light cannot escape. Light tries to escape, it gets bent right back around and falls back in.
They can shine more brightly than anything else in the universe. That's because as matter falls into them, before it actually falls into the hole itself, it falls into a rotating disk which becomes very hot and shines very brightly.
It was the much better resolution of Hubble, spatial resolution compared to ground-based telescopes, that allowed astronomers to look further out in space and yet still see the motions of stars near black holes and to verify that there were black holes there.
If there was no Hubble telescope, we would dimly perceive that there are black holes in the nearest galaxies, maybe the nearest 3 or 4. With Hubble, we've mapped almost 100 of them.
It was the Hubble that really allowed us to show that they were ubiquitous. Pretty much every galaxy that had one of these big ball of stars in the middle has a black hole in it too. And from that came the idea that a black hole is an integral part for how a galaxy grows, that as it builds up its outer structure of stars, gas, star formation, it's also dumping material into this enormous, tens of millions of solar masses of the sun in a black hole. In some ways, the black hole is kind of the ultimate expression of trying to understand basic physics that is beyond our experience here on Earth.
Two teams were racing each other to try to measure how much the universe was slowing down in its expansion due to gravity.
This is one of those cases where you want two different teams working independently to independently do this measurement and see if they come up with the same answer.
Instead, we found something even greater, which was a surprise that the universe wasn't slowing.
The universe was accelerating. Hubble helped by making some of the observations of distant exploding stars called supernovae.
Supernovae turn out to be a great tool to be able to tell how far away an object is just by its brightness.
So a certain class of supernovae, which we call the type 1A, always explode with about the same energy.
And that means that you can use it as a sort of standard marker. The fainter it looks, the further away it is.
And so in the case of these supernovae, we use them to track the expansion history of the universe.
Dark energy is a placeholder for this theoretical entity that we don't even know that is causing the universe to speed up in its expansion.
This is a repulsive kind of gravity. So, as we often say, if you took your keys and you threw them up into the air, this is the kind of stuff that would make them go up, not come back down. Dark energy is really pushing the boundaries of what we understand about physics. So we're hoping it's the clue that gets us to the next level of understanding.
To be able to use Hubble Space Telescope meant that we could actually make measurements that are precise enough that we can look for the small changes in the expansion history of the universe that can begin to give us some clue as to what this whole phenomenon is.
The Hubble Space Telescope was built to do this project, and in fact, the size of the primary mirror of Hubble was determined by the ability to measure the stars we used to make these measurements. Before Hubble came along, we didn't know the age and the size of the universe to better than a factor of 2. It was that uncertain. If I'm 25 or if I'm 50, that's a big difference. That tells you something very different about me and what my evolution has been, an understanding of me and where I've come from. What Hubble allowed us to do was to measure this precise age. The universe is 13.7 billion years old. It's between 10 and 20, but we narrowed that by an enormous amount. We used a particular kind of star that has a unique property that allows you to measure its distance. We have to find them in a galaxy that has a lot of other stars. And so getting above the atmosphere of the Earth lets us make those measurements very, very precisely, and only Hubble could do that. Once you can measure the distances to some galaxies very precisely, you can tie those measurements into the distant universe. You can see what rate it's expanding at now, and then you can, like a movie in reverse, calculate what its age is, run it backwards. I think it's one of the most exciting questions we can address in science.
Before the early 90s, there was no evidence for planets outside of our solar system. In fact, now we have hundreds of planets orbiting other stars known by the Doppler technique, which is a study of the star's motion wobbling back and forth. And it's only until recently, with advances in technology and the cameras aboard Hubble, where we've actually obtained a photograph of an extrasolar planet.
Paul, what was your reaction when you looked at the data and saw a planet that wasn't in our solar system?
I literally had what seemed to be a heart attack, because not only was I seeing this faint speck of light next to a star, but I could also see the orbit as the speck of light moved from year to year around the star. So all of a sudden, I wasn't just seeing a planet around another star, I was seeing its motion as if it was coming alive right there on my screen. It's one step towards finding another Earth. What we're seeing now are the giant planets like Jupiter orbiting other stars, because they're easier to see. When we study these other planetary systems, these other systems are not exactly like our own solar system. There are many pathways in which planetary systems can evolve. So we want to understand our place in the galaxy.
We're over halfway to completion of the deployment.
Hubble has morphed many times, and every time it's been fixed, or serviced is a better word, its suite of instruments has grown in power. And indeed, there have been many telescopes up there over time.
You build Hubble to do a particular problem, and then there are things that you never even dreamed of at the time that you were planning the telescope, and they turn out to be some of the most interesting discoveries of all.
We had a wonderful confluence of a telescope that turned out to be very robust and very stubborn about surviving, and people who could go up and tend to it and repair it. That's a record that'll be hard to break.
It's been the pioneer. And I think we will look back on the Hubble age as the golden age of astronomy.
We really now can penetrate some of nature's deepest secrets, and we can understand things that no one in the history of civilization has ever had the capability of understanding before.
For the past 20 years, the Hubble Space Telescope has revolutionized astronomy. Beyond its science breakthroughs, it has taken us along on an epic adventure through space and time. But some of its most exciting discoveries may still lie ahead.